Hello, welcome to Dutch-Taiwan Expertise Supply Chain in Floating Wind webinar. My name is Jennifer Chen, and I will be moderating the webinar today. Before we welcome our distinguished guests for opening remarks, I want to cover some logistics to make sure you get the most out of these webinars. Today we have over 130 participants who have registered, therefore we will not be able to answer all the questions in real time. But we do provide the WebEx software for a chat box. So anyone has any question could type in your text in the chat box, and we will answer all the questions in the Q&A sessions. The webinar today will be recorded. We will send an email to the webinar registrants with the authorized presentations files and also the recording files once the webinar is finished. And we would now like to start the webinar, which is scheduled to run for about 2.5 hours. First, we're going to welcome Mr. René Bierproef, Head of Economic Section and Deputy Representative of Netherlands Office Taipei. Let's welcome Deputy Representative René. Oh, sorry, you're on mute.
Mr. Beurskens, Mr. Schutten, both from Holland Home of Wind Energy, Professor Chiang from NTU Energy Research Center, Dr. Zhou from Chip Ocean Industry R&D Center, distinguished experts, ladies and gentlemen. It's my pleasure to welcome you all here today as industry stakeholders and experts in a discussion about the join this exciting ride with us and experiencing all the challenges and successes of offshore wind development on this island. And as you all know, Taiwanese authority recently announced that they are aiming to install a further 20.6 gigawatt of offshore wind generation capacity until 2035. And meanwhile, in the Netherlands, also renewables is at the core of our energy transition strategy. Especially offshore wind farms in the North Sea will be key to achieve the transition to a zero-carbon Dutch energy supply in 2050. And in order to realize these ambitions, we plan to develop an additional 10.7 gigawatt of offshore wind capacity by 2030. And going forward, we need more offshore wind capacity. And hopefully we can use our innovative capabilities in this respect to our advantage, like floating wind, which is being discussed today. And in particular, the Netherlands has been putting a lot of efforts in developing this floating wind technology. At this moment, all the support structures for offshore wind turbines are still directly mounted on the seabed. However, the cost of such foundations are becoming prohibitive in deeper waters. Hence, typically, beyond 50 meters depth, an attractive option is to place the wind turbine on a floating support structure that is moored to the seabed. The installation of wind turbines in deep sea presents many advantages. Winds are often stronger and steadier in these regions, yielding to more energy produced. And installation costs can also be reduced. At the same time, it also presents a lot of challenges which the industry still has to counter. And the whole offshore wind supply chain, ranging from wind energy conversion system, engineering and cabling, anchoring and mooring, is making the necessary innovative adjustments to make this happen. Today, a number of Dutch companies present who are part of this comprehensive supply chain, and they are working on these new floating wind models with leading companies like Gusto, Bosklais, Mammoet, and also with Taiwanese experts present today from NTU, Ship and Ocean Industry R&D Center, Swancore, we think we can work together successfully. And we believe that floating wind solutions are the future for markets like Taiwan. Therefore, this will be a leading topic for our office and our Taiwanese partners for the years to come. In other words, I consider today's session as a kickoff session for further cooperation in floating wind development in Taiwanese waters with Dutch expertise and Dutch technology. By the way, later in December 14 to be precise, in cooperation with World Forum Offshore Wind and our colleagues from the UK and German Trade Office, we will also put a mini-series of videos introducing Dutch and European floating wind technology on a YouTube video screen online. And last but not least, please feel free to contact our office if you need our support to facilitate your business here in Taiwan. I'd like to thank you for your attention and I wish you a very successful webinar. Thank you.
Thank you, Deputy Representative Renee. Thanks a lot for your remarks. And again, thanks for Netherlands Office Taipei's support for this webinar. And it would definitely be a great start to start the Dutch and Taiwanese floating wind dialogues for both sides. And now we would like to invite all speakers and also Netherlands Office Taipei to join us for the group photos. And so we need all the speakers to turn on their camera now. Is everyone camera on? Stephanie? We also will need your camera to be turned on. Yeah, we can see everyone. So we can have our group photo now. So 3, 2, 1, cheese. Okay, it seems very entertaining for a moment. Yeah. So maybe we could also have a thumb up for this photo to congrats our events. Yeah, everyone had, thumb up. Thank you. Jos, maybe your thumb is in other directions. Okay. So 3, 2, 1, cheese. Okay. Thank you. Then we're done for the group photos now. And thanks all the speakers for participating for our group photos. And now we'll enter our first sessions. Our first speaker is Mr. Jos Beurskens, the advisor to board of Holland Home Wind Energies. He has been retained as an advisor to the European Commission and several national governments on wind energy R&D programs. He's also the scientific director of Netherlands' first offshore wind energy R&D program, We4C. And he's also been the head of renewable energy of wind energy units of the Energy Research Centers in Netherlands, we known as ECN. Today, he will share with us on the floating offshore wind energy Dutch expertise, and let's welcome his presentations. Thank you, Jos. It's your time.
Okay, Mr. Beerpoort, and also the dear Taiwan guests and my countrymen, I would like to thank you very much for attending this short introduction in floating wind. And also the role of the Dutch industry in participating to the application of this new, relatively new form of wind energy. Next slide. Just a few words about Holland Home of Wind Energy. It's an export association and which supports the Dutch industry in their exporting activities. By participating in trade shows, by webinars, etc. There's 45 members, and those members actually cover the entire supply chain. Next one. Next slide, please. Many people think that floating wind is a new application, but to my surprise, in my notes and also from my colleagues, I learned that in 1972 already, and it is 1 year before the first oil crisis started. Bill Hieronymus, he was a US Marine officer, proposed a large wind farm consisting of 165 stations of each 6 megawatt to put offshore near at the east coast of the United States. And he also proposed to generate hydrogen, to store the hydrogen in subsea underwater reservoirs and transport it to the coast. And here we are, trying to pursue actually an old idea. But what is the difference between 1972 and now? And actually there are two. First of all, we have many more technologies available to realize those large projects in a cost-effective way, possibly. And secondly, the urgency. In 72, of course, we felt there was a crisis, but we didn't feel the effects. But now there is also a common sense that there is a crisis, but we do feel the effects. That's the big difference, actually. But let's look now at the present situation. Next slide. Between 72 and now, quite a bit of research and demonstration happened. After a decade of relatively quietness in this area, 1993, research started both on national levels, but also within the IEA and within the EU projects were initiated. And there are many projects which were carried out. But here are the key topics. Of course, we have been looking into resource assessment and mid-ocean conditions, which is actually an input for the design of the total system. We have been looking in the taxonomy of support structures, in the dynamics of both the underwater world, so the foundation, and what happens above the water level, so the structural dynamics, the aerodynamics, and the aeroelastics of the wind turbine. And the big challenge is to integrate those two actually separate scientific worlds. And to a great extent, this happened already. And then came a period of specific design studies and actually designs, prototype testing we have seen in a number of countries. The first demonstration projects are in operation, and now we are at the brink of a large commercial application. And in parallel with the commercial application, also the research into optimized logistics, port facilities, for instance, transport installation systems, and operation and maintenance is starting. And if you ask the experts, they say, well, actually there's no essential gap in the know-how. There is plenty of room for improvement, but all the essential elements of what we need to do to build those farms is available. And if you look at what happened in the past, I'm very pleased to see that the Netherlands were involved in almost all the important projects, either on EU level or IEA level. Next slide, please. If you look at the foundation types offshore, you can say that for each water depth, there is a specific foundation type. On the left side, you see foundation types for shallow waters, varying from concrete slabs, gravity foundations, to jacket foundations. And if you exceed water depths of about 50 to 60 meters, it becomes very interesting to look in floating designs. And they again can be roughly divided. There are many more concepts now under development, which are sort of a hybrid between the three I will show here. That's ballast stabilized foundations, like spar foundations you see on the left. At the right side of the picture, you have buoyancy stabilized foundations, like semi-submersibles, and you have tension mooring stabilized foundation. So you pull down a floating foundation, and the tension in the mooring lines provides for stability. And in the next slide, I will show you that a choice is rather complex. And next slide, please. And if you look carefully at that slide, you will easily come to the conclusion that there is, for the time being, no convergence in foundation type predictable. On the one hand, you have the types on the horizontal axis, and on the vertical line, you see the aspects you have to look at, like the relative steel mass, which is connected to cost, critical water depth, transportation, transportability, and port facilities, mooring complexity, etc., etc. The line, this list is longer, but the scores for the different types of foundations are different, and the process of optimizing is very complex, I would say. And that's why we will see many options in the near future, which are, for the time being, very, very good. Next slide. An interesting issue is the potential of offshore wind. So in general, if you look at the maps, you can conclude that the total wind resource in deep water, not far from the shore, is more than the resource in shore, near the shore. Something wrong. Anyway, the DNV, for instance, and we have now 100 megawatt of offshore and floating, and we will go to 250 gigawatt by the year 2050. That's 2% of the world electricity supply from floating structures, and 20% of the total offshore market at that time. And here you can also see some promising countries which are already active in the field of floating offshore wind. The next slide, please. Next slide, please. A rough picture of this supply chain of floating wind in general. On the blue boxes, you see the details, and on the red ones, the major blocks, the major elements. And I will use this picture to show you a little bit about what the Dutch industry is now providing. Next slide, please. Services and products. Is there something wrong with the connection? Next slide, please.
Also, the connection is not so good, I believe.
Okay. Can you all
I think
see
it's a connection from Jos.
Is that so?
There encounter some connection problems. Jos, can you hear
Is
us?
it okay now?
Yeah, it is okay now. Yes.
Okay.
Thanks.
So the first slide refers to the contribution of the Dutch wind energy community in the field of pre-competitive research and education and training. The major institutions here are MAREN and TNO. MAREN has a lot of basins, an offshore basin where models of floating foundations, among others, can be tested. And TNO is specialized in the wind, especially specialized in the wind turbine and the dynamics of those. And both parties work very closely together to integrate those models. And quite a number of models have been tested in the basin, also to validate the prediction models. Next slide, please. In terms of project development, and which also includes financing, I would like to mention as examples, that's not a complete list, example Green Giraffe and Shell, which acquired Ionfi recently, which is a French tension leg developer. So in that sense, there is expertise and facilities available. Next slide, please. This is now we are going to technology supply. This is an example of companies who are very much involved in engineering. Mr. Beereport just briefly mentioned them. SBM Offshore is an example. You see on the right side an example of their activities. Gusto, MSC, NFV, Blue Water, and Monobase Wind. And the next slide, you will see some more examples. That's in this block. Anchoring and mooring is an activity which is carried out, for instance, by Vrijhof. DSM Protective Materials produces fibers like Dyneema for making mooring lines, and Fibermax makes cables from those fibers and also fibers from other manufacturers. And there are two companies in the Netherlands active in wind turbines, which are particularly suited for floating systems, which is 2B Energy and Seawind Ocean Technology. We go to the next slide. And here you see the transport and installation section of the supply chain. Bosklais is already active. They have, among others, provided the transport facilities for the Kincardine project in Scotland. Mammoet, heavy equipment, and EQIP, which was involved in installing the Hywind project in Norway as a contractor of Saipem. Next one, please. This is a little bit of a strange part of the supply chain. It's I skip, by the way, operation and maintenance, because there are no companies yet which are working for floating wind, but they are all working for a bottom fixed offshore wind farm, and it's not too strange a step to go to floating wind activities if it comes to operation and maintenance activities. But of course, there are particular differences. End-of-life solutions become more and more important. The dilemma is that we have to take those aspects of the supply chain into account 25 years in advance of the actual activities. So it has to be an integrated part of the design process. And there are a lot of developments and studies going on already, but it has to be included in the project design once again. And there are two things which are particularly important. That's the remanufacturing part. So the rotating part might be refurbished to be applied in new wind turbine systems. This is a thing which can be adopted to a great part from the automotive industry, where remanufacturing is a big thing. So you cannot buy a new car which does not have a remanufactured part in it already. So that's something to look at it, and it requires quite a bit of standardization to make this process industry-wide a success. The other one is the availability of precious materials from generators, etc. So that strengthens the need for recycling. The next slide, please. Just a brief look into the future, which also reflects the challenges we are facing. We are on the brink of an application. All the basic technologies are there, but we could reach probably much dramatic cost reductions if we go to serial production. This is conflicting actually a little bit with the requirement that each foundation is specific for each location. And one way out, and we see already the first demonstration project in that sense, is to build those foundations as a toy mechano box, for instance. So the elements are standardized, but the structure itself is specific for each location. I think that's very important. The further validation of models, of course, is important, so we can design structures in the future more critically, and thus also cheaper. One thing which I personally find quite interesting is sharing operational data for standard development, and in particular accidents and incidents experience. In the beginning of the wind energy development in the 70s and 80s, this was essential, that there was an open exchange, and it led to standardization, international standardization, and that also stimulated international trade quite a bit. And I'm going to see also such a development in offshore wind, in particular the floating foundation applications. Of course, transport and installation optimization, it's very important also to make choices. It is very important design parameter for foundations. And the designers say, once we have a foundation, we want to have as big as possible wind turbines on that foundation. So we probably are going to see also quite a bit of upscaling of wind turbines, maybe even bigger than the biggest one, which is now under construction, which has a diameter of 236 meters. And finally, in the next slide, please. I'd like to show you this. How is the further future going to look like? So we started in the 70s with quite a futuristic design. And what is the future actually going to see? And of course, we do not know, because we have been faced with surprises all the time. But maybe we are going to see fully dedicated designs like vertical axis machines, like multi-structures on one foundation, or even systems which do not have a rotor anymore and even do not have a tower anymore, like the airborne systems, which I've given here a picture of a Dutch company which is developing this. And last but not least, government policy. If you go offshore, the government could de-risking these huge operations quite a bit by doing the preparatory work, like the generation of met-ocean data at the particular sites, to do the physical planning in their waters, to provide for the energy infrastructure, both electricity and gas in the future, hydrogen, and also to provide for artificial islands, which might have more functions and which could serve as a service point near an area of gravity where wind farms will be created. So this is what I would like to say as a sort of an introduction to the presentations which will follow. And I'd like to thank you very much for listening to this introduction.
Thank you, Jos. Thanks for the introduction of floating wind supply chain in Dutch. And also, it is interesting to learn the history of floating wings. And also, we do know that government policy will be definitely boost to accelerate the development in floating wing. And then next, we're going to welcome Professor Mao-Hsiung. Professor is a well-known professor in the offshore wind industry in Taiwan, and he's also the key person for the offshore wind farms bidding and localization reviewing process. Professor received his doctorate degree in Aachen University in Germany, and his expertise in field of wind power system dynamic analysis control and advanced village power control. He's now the Associate Dean of College Engineering of National Taiwan Universities, and also the Director of NTU Energy Research Centers. And he's now also taking the lead of Ministry of Science and Technologies 15 megawatt floater research projects. He will share with us today on Taiwan floating offshore wind development outlook. Let's welcome Professor Jiang.
Thank you, Jennifer, for your introduction. Good afternoon, ladies and gentlemen. In the next 15 minutes, I would like to talk about the outlook of Taiwan floating offshore wind development. And I'm Mao-Hsiung. Next, please. And before we discuss about the outlook of Taiwan floating offshore wind, we should know first the current status of the international offshore wind. And in this figure, you can see the cumulative global development of floating wind, offshore wind. And by 2022, you can see it's about 128 megawatt has been developed. Next, please. the trend is quite clear, and the floating wind development and the demand increase quite soon. And in this figure, you can see the global floating wind project. The first one is the high wind one in Norway, in 29, and then after that in Portugal, in Japan, Fukushima, several projects has been conducted, and in 2017, here we can see the high wind Scotland. The installation finished in October 2017, and the 6 megawatt Siemens wind turbine, 5, and the total is 30 megawatt has been installed, and it's spa boil type for the water depth 95 to 120 meter, and I think in this case it's quite. The result is quite amazing because the capacity factor you can see from last year, the average capacity factor is about 57.1%, and the average for the last 2 years, the capacity factor is about 54%. So it's quite higher than the capacity factor in the offshore wind farm with bottom fixed type. So I think is for us, we are interested for the floating offshore wind development in Taiwan, and the result is quite also very positive for Taiwan to promote the floating offshore wind in the future. And also we can see the kindergarten phase 1 and phase 2 next please. And it just finished this year. It's 50 megawatt, and the water depth is 60 to 80 meter. It's quite similar to the situation in the Taiwan offshore wind farm, and they use floating semi-submersible foundation, and 9.5 megawatt Matrix Vestas wind turbine is used. So I think this wind farm is quite similar to Taiwan offshore wind farm in the future for the floating application. Next, please. And by 2021, we can see totally this spa type is 7, and semi-submersible is 12, and the tension deck is 1, and barge is 2, and several different type of the floating offshore wind has been investigated and demonstrated in different projects. And here we also can see the trend is more and more clear, right? And the spa type is suitable for deeper water, more than 100 meter water depth, and the semi-submersible type is suitable for the water depths lower between 50 to 100 meter. And in Taiwan Strait, the water depth actually is lower than is under 100 meter water depth. So semi-submersible type maybe is suitable for Taiwan offshore wind farm in the future. Yeah, next please. Yeah, and in this figure you can see the upcoming offshore wind project globally. And in 2022 and 2023 in Japan, Goto in near Nagasaki in Kyushu is the spa type, and then in Norway, in Ireland, Spain, France, and USA in the University of Wien. So here we can see before 2023, the project actually is still a pilot project. Most of the project is pilot project, and next please. Yeah, and if we look at the technology readiness level, the TRL, so-called TRL, and you can see, separated by the floater developer, like Principal Power, Idiot, Naval Energies, And you can see only principal power can achieve the TRL 8. And the wind farm Kingarten just finished in this year, so it just crossed the TRL 8 to 9, and the rest actually are lower than TRL 8. That means the technology is still under development, and even the pre-commercial wind farm are just begin. And so we have a look at the demand in the future in Taiwan, and we see we just in compare with the bottom fixed type, we have still the opportunity, and we still have some time to develop the floating offshore wind in Taiwan. Next, please. Next, please. Next, please. Yeah. Now let's have a look at it in Taiwan, and I think many people have ever seen this map. Is the wind farm distribution in Taiwan. Yeah, and the shallow water first of all is 1.2 gigawatt. Deep water is 10 gigawatt, and the deeper water more than 10 gigawatt. So the Taiwan government also now focus on the net zero emission by 2050. So actually, in the recent months, I have joined many meetings with the Taiwan government and like BOE and MOE, and to discuss how to achieve the net zero by 2050 in Taiwan. And actually, offshore wind energy, offshore wind power will play the most important role to achieve the goal. And next year we will open the phase 3 zonal development, and another 15 gigawatt will be open, and more than 10 gigawatt flexible wind energy in the deeper water zone will be open. So now floating offshore wind will be in demand in Taiwan in the future. So also the localization of floating wind will be expected. Next, please. And in this picture, it's more interesting is the average wind speed at 100 meter high, and you can see the best wind condition actually most is in the field of the water depth more than 50 meter in the Taiwan Strait. And another side that we can see is in the southeast is a small island, the Green Island. Green Island. Yeah, in the Green Island actually is the average wind speed is also more than 8 meter per second. And but the problem is in this side the water depth is many hundred water depths. So the water depth will be a problem. And also in this side the typhoon always hit the island. So the floating offshore wind turbine installed in this area helps to conquer the problem. Okay, next please. So in the phase 3, next year the Q1 and Q2 where the bidding will be open. So we will have another 50 megawatt by 2035 will be open. Okay, next please. So the EIA consent, we still have about 5 gigawatt in the area of water depth lower than 50 meter. That means the bottom fixed wind turbine can be installed in this area. Besides that, the area with more than 50 meter water depth. That means the floating wind turbine will be in demand in this area. And also for the floating wind, the localization will be expected. Okay, next please. In this table is the commitment of local supply chain. And the foundation always is an important item, including the floating wind foundation, including the boiler, the platform, floating platform, the mooring and anchor system. Next, please. So now, actually, in 2021 in Taiwan, we have only two main projects conducted. One is in NTU, and the other one in SOIC. And I'm now would like to show you a short introduction about the NTU floating wind team. And we, including besides me, we have Professor Yang and Professor Xiu Zhao, Professor Kai-Dong Ma, Professor Jinpa Zai, and also another two professors, Professor Hong Yue Luo and Professor Junhong Lin. Okay, next please. And in this project, we also cooperate with several different, including the industry and the research institute, and also international linkage. Yeah, next please. And I'm the PI of the project and also the sub-project one. Next please. In this project, we will develop the dynamic analysis and control of a 50 megawatt semi-submersible floating wind platform, and including the couple aero hydro servo elastic dynamic simulation of the overall system of a 50 megawatt semi-submersible floating wind turbine. And we will integrate wind turbine floating platform and mooring system, and to analyze and to input the condition of the Taiwan offshore wind farm. That means the water depth will be between 50 to 100 meters. Now we use the water depth is 75 water depth, and the model including the turbine and the generator and the grid side model, and also combined with the floating platform model. Okay, next please. So we first established the dynamic model of the 50 megawatt wind turbine, and also we try to analyze a suitable site for the future. I will talk next in the next slide. We would like to have a R&D demonstration project. That's a suggestion for the government. Next please. And we also established the floating platform design and the dynamic model, and then implement the co-simulation with the software fast, simple, and MATLAB together. Next please. Next please. So very quick the figure. It's a result of our research of 10 megawatt floating offshore wind turbine with the IEA platform. So based on the model, actually we can verify the design of the platform and the coupling interaction between turbine and the platform. So the next step, we will verify the new platform developed by SOIC and combined with our wind turbine. Next, please. The sub-project is did by Professor Xiu Zhao. Next, please. And you can see the hydrodynamic analysis will be developed here. Next, please. And the seakeeping analysis will also implement in this sub-project. Next, please. And we also will analyze the extreme condition for the floating of offshore wind. Next, please. And also in the sub-project 3, we will develop the mooring and the anchor. So in sub-project 2, we also implement the motion analysis of the gravity install anchor. And the sub-project 3, actually the PI is Professor Katie Ma. Yeah, Katie Ma is expertise in the mooring and anchor, and they have more than 30 years experience in the oil and gas in Houston, USA. We just invited him to come back to Taiwan to join our team. Next, please. And the co-PI is Professor Sung Yang. He also just come from Sweden, from Europe. He just joined in the 15 megawatt wind turbine project in Sweden. Yeah, next please. So in this sub-project, we're including the floating platform design. Next please, for the 50 megawatt semi-submersible and the floater dynamic motionless, which will be cooperated with the ship and the ocean R&D center, and we will work together for the development. Yeah, together. Next please. And also the mooring system design for the Taiwan water depth and the Taiwan soil condition of the seabed. Next please. And in this project, we also try to investigate the anchor, the gravity installer anchor. And we still have no idea if the gravity install anchor is suitable for the soil condition in Taiwan wind farm. So in this project, we will try to investigate. Next, please. And also the dynamic cable system design. As you know, the problem actually is more serious for the shallow water. So in the Taiwan Strait, actually the water depth is between 50 and 100 meters. Actually, the dynamic the dynamic cable problem will be serious. Yeah, next please. And in the sub-project 4 is the Professor Jinfa Cai. Next please. We will conduct a model test in the towing tank of our department. Next please. Yeah, it's IEA 15 megawatt wind turbine, and we will combine with several different type of the floater, including the IEA floater and the floater developed by SOIC. Yeah, next please. And we can compare the performance not only in the model test but only in the simulation. Okay, next please. Yeah, now we can have a look at the TRL in the Taiwan, in the project in Taiwan now. Actually, in the two projects, not only in the project in NTU, but also in the project of SOIC, the two projects actually now can achieve the TRL4. It's a tank test. So in compare with the project in international, actually we are a little bit slow. So we have to accelerate the development speed for the floating wind in Taiwan. So what's our next step in Taiwan? Yeah, we serve as a third party in Taiwan, and between Taiwan government, we give suggestion and comment for the Taiwan government, and we also give comment and suggestion to the wind farm developer. And so we try to give the suggestion for the right way for the floating wind in Taiwan. And so we have to not only in Taiwan, but also we have to see the situation, especially in the APEC country like Korea, South Korea, and Japan. And as you know, now the Korea government have announced they will have a goal of 12 gigawatt in Wusan wind farm, and including 6 gigawatt floating wind by 2030. So I think it's for Taiwan. Now we have the advantage in the development of the offshore wind. But the next step in the deep water zone. The water depth more than 50 meter. And what's our advantage? Actually, we are now actually a little bit slow. The development speed is slower than Japan and Korea, South Korea. So next, please. Next, please. So the outlook is, we now try to combine the wind farm development in Taiwan and also the supply chain industry and the research institute like SOIC and our in the university side in the NTU to achieve the Taiwan floating wind team to accelerate and promote floating wind development and design, analysis, manufacture, certification, installation, and regulation of the floating platform, mooring, and anchor in Taiwan. And the first, we would like to promote the Taiwan floating wind R&D demonstration project for 1 to 2 megawatt scale by 2025 to verify the R&D and the performance of the R&D. And the next step is to promote the pre-commercial project for 100 and to 200 megawatt scale. But the time point actually is just under discussion because just as I mentioned, in compare with the Korea government, in Korea, by 2030, they will have 6 gigawatt commercial floating wind farm. And what's our next step for the pre-commercial project by 2027 or 2028? It will be a suitable time point. And after that, we can have a commercial floating wind farm by 2030 or 2029. So besides the floating local supply chain, but also very important. So in our project, we also cooperate with the CSBC, and they would like to serve as a potential local supply chain for the floating wind in Taiwan. And besides that, the international cooperation is significant for floating wind development in Taiwan. So we are also looking for the cooperation in the future with the international, like including the Dutch government and the Dutch industry. Okay, thanks for your attention.
Okay, thank you, Professor Zhang. Thank you for the very precise detail about the research data and the research team of Taiwan floating research projects. And next, things were a little bit delayed, and we will accelerate our agendas. And next, our speaker is Barend Jenje. He's the Commercial Director of Floating Wing Tri-Floater in Gusto MSC. He has been with Gusto for more than 5 years and is responsible for commercial activities for floating wing foundations. And he will share with us about the product innovations in floating wing Tri-Floater, serious production of floating platform. Let's welcome Barend.
Thank you very much, Jennifer. Thank you very much for this opportunity. It's good to see Taiwan being active again in floating offshore wind. The market is big, so we need to prepare ourselves. Next slide, please. So we are Gusto MSC. We are an NOV company. NOV is a stock-listed company in New York. We're about 27,000 employees, and we are all over the country wherever there's oil and gas and offshore wind available. Next slide, please. You may know Gusto MSC from their wind turbine installation vessels. We are a market leader when it comes to the designs of those vessels. If you look out there in North Sea area, there's about 70% and 0% being installed with our designs. Next slide, please. With the ever-growing turbines, also the jack-up installation vessels are growing. We are already looking at today's 15 megawatt turbines And for future discussions with contractors, we are looking at 20 megawatt turbine to be installed with these type of vessels. But from fixed wind, we go to floating offshore wind. Next slide, please. Next slide. Here's a short movie I would like to show you. This indicates the status that we're into today. You're looking here at our third generation floating foundation. We started our floating wind activities already in 2001, requested to do so by Dutch government. That was a consortium of companies, including Marin, including ECN TNO, Technical University Delft, and at that time a turbine company called Lagerwey. We were looking at tubular versions of semi-submersibles. In 2013, we changed that to a flat-plated deck box construction. That's a picture you just saw at the previous presentation. And today we're looking at our third generation, scalable for 15 up to 20 megawatt turbines. The new third generation tri-floater. This tri-floater has just been tank tested in Oceanida, France. It's a combination looking at the flat-plated welding industry and making use of existing bracing industry. The most important thing when it comes to floating wind is all about supply chain. You may note that there are at the moment over 100 different designs out there. They have all their pros and their cons. What we see is that fabrication and assembly of these type of structures is crucial. You need to find proper assembly sites, you need to find proper fabrication sites. The floating wind world is dominated by local content requirements set out by the different governments, and for that you need to be prepared to do local activities. Next slide, please. So again, we are looking at a 15 megawatt plus design. If you want to have smaller turbines, also possible. We also can use this unit, so it's also scalable downwards. Again, a braced semi-submersible structure with the turbine positioned in the midst of the two main columns. Next slide, please. The benefits of using semi-submersibles for floating wind, including the heave plates that we have, is that we keep the acceleration level of the nacelle as low as possible. These requirements are set by the turbine manufacturers, so the cooperation with turbine manufacturers in the design of your floater is of essence. Next slide, please. One of the main benefits, also one of the crucial items within the supply chain, is the availability of harbors, local ports where you can do turbine installation or where you can do the launch of your fully assembled floater. For that, our structure, the tri-floater, has a limited draft. After launch, after assembly, we are looking at a draft of 5 meters, and with the turbine installed on top of the floater between the two main columns, the draft is about 10 meters. Why is this important? The amount of harbors that have deep water depths is limited. So there are a limited amount of harbors out there that have drafts, where drafts are capable of 15 meters and more than that. So to prevent expensive infrastructural activities or dredging activities in harbors and making use of harbors as much as possible from a local perspective, a limited draft is beneficial. You can make use of more harbors. The amount of floaters expected in 2030 to be built and installed is about 300 units on a yearly base. That is exceptional. There's a lot of steel going on. There's a lot of installation activities going on. So multiple harbors will need to be involved with these activities. You cannot rely on those few harbors that have these deep water depths available. So we feel that draft is essential in the full supply chain of floating wind. Next slide, please. One other aspect is the availability of large cranes. Turbine installation can be done from quayside, but as also can be done from port side. There's a limited amount of onshore cranes available when it comes to the big new turbines, and ensuring that there's sufficient capacity when it comes to lifting activities. Today's wind turbine installation vessels out there that are doing the 11-12 megawatt installation works can also do 15 megawatt turbine installation works in port. So to prevent for these ship owners that their vessels will be outdated for the new 15 and 20 megawatt turbines, there is a new life for them when it comes to turbine installation for floating offshore wind. So you will see these units in and around ports doing lifting activities, just keeping themselves busy and preventing that there will be a supply chain bottleneck. Next slide, please. We look not only at CAPEX, also at OPEX. From an OPEX perspective, passive ballasting is a plus. Passive ballasting means that we do not make use of pumps or other equipment to move around ballast water. After installation of the turbine, we will tow out the structure to a deeper location, deeper water location. We will either fill it up to a towing draft, or we will fill it up to a full operational draft of the structure. We will then tow it out to the final destination of the floater, and there it will be anchored, connected to the mooring system. Having no pumps on board, or making the full system, the foundation, as dumb as possible, only plain steel without too many instrumentation on top of it, will prevent that in case of failure of this instrumentation or equipment, will prevent that you will need to go out with crew transfer vessels or service vessels 200 kilometers offshore and to do repairs on pumps or other equipment. So we promote a passive ballasting over active ballasting. Next slide, please. The floater that we design is for extreme environmental conditions. Based on the different locations, we will do custom built designs. So a floater for US will be different from a floater for Taiwan, which will be different from a floater for North Sea area. The environmental conditions are different, the wave conditions are different. Also, a different turbine will come with a different floater design. So again, custom built for project specific. Next slide, please. So when it comes to fabrication, we have two options. Here you see the option of flat plated, making use of local shipbuilding facilities or local steel building facilities that have panel lines available, enables us to use the hexagonal tri-floater version. So the three main columns are hexagonals. These can be welded and fabricated in normal, straightforward steel construction facilities that have panel lines available. The column where the turbine is positioned is a column which is similar to today's transition piece for fixed offshore wind. So that's already an existing industry. And the same for the bracings. There is an existing bracing industry out there where we can order all the different bracings for the floater. So we try to make the supply chain as easy as possible. If and when tubular industry is available from a local perspective, we can design the three main columns also from a tubular perspective. This will save a little bit of steel, but we note that quite a number of shipyards and steel manufacturers out there prefer to work with hexagonal versions rather than the tubular versions. Next slide, please. We will bring blocks to a assembly site. That can be the same site as fabrication, but typically the assembly site will be closely located to the final destination of the floater itself. We will bring in blocks as much as possible pre-outfitted to the assembly site. The bracing structures will potentially also be pre-outfitted, making the assembly process as easy as possible. The key site that you look at there would roughly be about 500 meters. You may think that the structures are big. Yes, these structures are big. They are about 100 meters in length and 30 meters high. But any type of floater you will see out there, whether it's a semi or whether it's a spar or whether it's a TOP, will request for large key sites available to do the assembly and the launching site. Again, talking about 300 units on a yearly base, assembly sites typically would have capacities of 15 to 25 units on a yearly base that they can build. And that again requests for large sites available to do the full assembly. And for that reasoning, you want to make your assembly as easy as possible. So pre-outfitting and doing works that you can do at the bracing manufacturer as much as possible. Bring it to a single location and you do the welds that you need to do. Next slide, please. So this is all about Gusto MSC in our portion in it. Within NOV, we also have some additional solutions that we offer to the market. Next slide, please. So together with our sister company NOV APL, we can do the full coupled load analysis ourselves. They are mooring system designers. They design the full lines for today for the oil and gas market. And we have done a number of projects with them when it comes to floating offshore wind. They're experts. Not only do they look at the mooring system itself, we also look with them and another NOV company called NOV FPS to the dynamic cabling and the way it needs to function and lay in water. Next slide, please. With that also comes connectors and tensioners. We have a manufacturer in our company that can do the manufacturing and design of tensioners and connectors. That's NOV BLM based in France. Next slide, please. All outfitting material needs to be out there for, like the floater itself, for 25 to 30 years in marine environment. If you make the outfitting material like stairways, like handrails, bulwarks, everything you can do as outfitting, we will propose that to be composite. Composite has the advantage that it has a longer lifetime than steel in the marine environment. There will be no corrosion, so paint jobs will not to be done within every five years. We also do the small cranes and davits on top of the structure. That's all in-house activities. Next slide, please. Within the field of floating offshore wind, there's a big portion when it comes to the inter-array and export cabling. For that, we have solutions for support vessels. We do full spreads of cable lay. We design, engineer, and manufacture the carousels. We do tensioners, cable lay tensioners. So all activities on cable side we can support. Next slide, please. And last but not least, more and more we see the combination between wind, offshore wind in general, and hydrogen. And within the hydrogen region, we have solutions when it comes to subsea storage of either hydrogen or ammonia. And we provide all kinds of flexible lines to transport hydrogen and ammonia to and from the electrolyzing unit or back to shore. This is what we offer, and this is how we feel that the supply chain of floating offshore wind should be made more easy. Supply chain for floating offshore wind is complex. It's not only about the design, but it's in the end from cradle to grave. It's from design up all the way up to assembly, all the way to fabrication, installation methods. And in the end, you will need to bring the unit after 25 to 30 years back to port and do the decommissioning of the unit. And for that, the steel of which the structure is made of can be reused and can be brought back to the steel mill and reused in full. So that is what we do. Thank you very much, and hope to hear some questions from your side.
Thank you, Barend. Thank you for your presentations. It's really good to know that in the floating life cycles, Gusto has able to custom build all the process and all the products. And next, let's welcome Dr. Jos Beurskens. Dr. Jos is from the Ship and Ocean Industries R&D Center. He's also the CEO of the centers, and they are a center that could be say is now the leading of Taiwan's floating floater design concept. And today they will share with us about the Taiwan floating floater design concept. Let's welcome CEO Jos Beurskens.
Yeah, thank you, Jennifer. Good evening, good afternoon for the friend from Taiwan, and good morning for the friend from the Netherlands. And I'm Jos Beurskens, the CEO of the SOIC, SOIC. What I present today is more or less something is similar to what is have been presented from the Gusto. So next, please. First, I have a very brief introduction of who we are. The former name of the SOIC is USDDC, United Ship Design and Development Center. We established 45 years ago from the Ministry of Economy, National Defense, and Transportation. And the main goal of us is for shipbuilding. And then 10 years ago, we transformed into including the marine and ocean industry as one of our developing goal. Next one, please. Why SOIC? Because we think in the platform in Taiwan that mostly the floater is provide a buoyancy to provide support a wind turbine. In Taiwan, we think the most suitable for Taiwan is semi-submersible type floater, and it's very similar to the ship design about the stability, seakeeping performance, and the structure analysis of that kind of floater. So we have 45 years of design experience in ship shape structure. So we are quite suitable for this kind of development. And I will introduce some research project about in this area, and we have also some marine operation assessment in marine warranty survey. So if you are interested in this, we can have further contact about this. Next, please. We have the project in this semi-submersible from the 2013. Start from analysis, and we do the model test from 1 to 100 model scale to 1 to 64 model scale, and then recently we do 1 to 20 model scale in the Amping Harbor for the field test, and some analysis and some validation of all the performance. Next one, please. And as the Professor Jiang has mentioned, our target is in Hsinchu area. The water depth is about 50 to 90 meter. The wind turbine is for the upcoming, the big wind turbine, semi-submersible, and the mooring system adopt is the catenary system. Next one, please. The specification and constraint for the design is we have the mid-ocean data, including some typhoon record. The wind turbine is IEC T-class wind turbine. And the extreme condition data is from Hsinchu buoy and some calibration simulation for 20 years in Hsinchu area. In this design, we consider the capacity of local supply chain, including infrastructure for fabrication site, shipyard, the dimension, the constraint for assembling port, shipyard, like the previous one had mentioned, the water depth, and the logistic for the transportation and installation. And we put all this constraint into our concept design. Next one, please. So we do all the design process from overall platform design, mooring design, detailed design, fabrication, and the following well design, I will introduce each phase. Next one, please. First, the floater is, you can see that somewhat similar to the tri-floater. It's called a floater. It's data flow. We have 3 columns, semi-submersible type 3 column. Shallow water, we have underwater pontoon. The pontoon is for ballast water to keep it in lower center of gravity, for the good stability and to reduce the seal weight. And the natural frequency for this platform is longer than 20 seconds, so we can avoid the natural frequency to coincide with the wind or wave condition. Next one, please. The data flow also meet the requirement for installation and wear towing condition, and for that kind of requirement for the process, and compared to that regulation requirement, in all process, the maximum static till angle is below 10 degrees, and it can be installed the wind turbine in harbor or in shipyard. Next one, please. The principal dimensional spec of the data flow from this stage is that we have the centroid to the column. The meter is 40 meter, and the column diameter 12.5, and the pontoon height is 7 meter. The design drop 20 meter, and displacement, including the ballast water, is almost 20,000 tons, but the steel weight is less than 4,000 tons. The minimum draft in the transportation is only less than 4 meter. Next one, please. So we have some structure design to simplify the structure. The connection for the upper structure is no bracing. It's only minimal bracing to reduce the fabrication process. This is some pontoon section, top view, profile view, and the connect of the pontoon. Next one, please. Yes, next one, please. Okay, this is some stress distribution of the structure under the loading from different wave condition analysis for demonstration. Next one, please. Okay, this is for the mooring system design. The mooring system, we designed 2 types of mooring system. One is 3 plus 1 chain, a larger chain system. And the other one is 2 chain for each column. So it's 3 plus 2 chain. So that in larger chain system, and the small system is for design for redundancy. If one chain is break, it can still hold it in to satisfy the minimal safety requirement. Next one, please. So the design is under the 3-hour John swap wave dominate condition. We find that this is the most critical condition for the Taiwan condition. And in this condition, that the surge, the maximum surge for all condition, lifetime condition is the surge is less than 20 meter area. And we can see the time domain analysis of the response for the whole thing for the 3-to-1 condition. Next one. 3-to-2 design is what we call a redundancy design condition, designed for For the ABS is designed to 50 years design condition from different coming wave, 90 degree, 135 degree, 180 degree condition for the time series. Is surge still is even in the one line break condition, the surge is still less than 20 meter. Is the we see in the practice in this kind of ABS practice. Next one, please. For the dynamic cable, the power cable, a different kind of dynamic cable design. We found that in this kind of so-called shallow water condition, we find that most suitable is the lazy S shape arrangement. Next one. This is the condition for the extreme condition. Even in this kind of A shape, we still need that kind of middle water arc to confine the motion of the cable. So that is the bend radius and the tension analysis is within the safety requirement. So actually, in this kind of shallow water in the extreme, like a typhoon, it's very challenging for the mooring system design. We found out that even more difficult than deeper water in this kind of like 60 meter water depth. It's more challenging than the deeper water condition. Next one, please. And we design the ballast system is that we have 6 ballast pump, 2 in each column for redundancy arrangement. We have the passive ballast tank and the active ballast tank. The passive ballast tank and the pontoon is for adjust the draft for the transportation and for on-site. And we use the active ballast tank system to transfer the ballast water between the column and the piping system to adjust the trim. And we can fulfill that we will adjust the trim and the leveling the platform in 30 minutes for all cases to keep it in the upright condition to keep the turbine's performance. Next one, please. So we have 2 cycles. The external cycle is to adjust the draft. We have an internal cycle to adjust the trim. So 2 systems to operate and be simultaneous or operate individually. That can be done. Next one, please. So we use this to show we have that kind of semi-submersible floater design. We have blast system, we have power cable analysis, and we have catenary system. So most of the data and is have been go through that kind of concept design process. Next one, please. So actually, we have to go through all the design for the Taiwan's concept design, and following, I think we have a video to show that kind of result for your reference. Yes, please. Data flow, the principal dimension which we have showed in the presentation. It starts from the fabrication site, even in the shipyard or in the shore site, and the wet towering to the fabrication yard. And then going to the assembling harbor to install the wind turbine. We have to consider the crane capacity, upcoming wind capacity. So maybe it should be assembly separated, not in one time, but several times, because of the crane capacity right now is not good, big enough for one time installation. Maybe we have to separate into several operations. And then we have to wait towering toward a wind farm site. When go to the wind farm site, the wind mooring line connection to the preset mooring system, chain system. And that's the extreme condition. Under extreme condition, the dynamic response for the mooring system. This is most critical condition, the time history of the analysis. It's the moving of the dynamic cable. The midway arch can reduce the motion of a cable so that the bend, the tension and the bend radius can be within safety limit. So for the conclusion that we can see, we have go through all the process and have some preliminary result for the design for Taiwan. So the data flow is the design from the SOIC based on the 45 years appearance in this kind of ship shape design. And thank you for your attention. Thank you.
Thank you. Thank you, CEO Zhou Xianguang. Thank you, 执行长. And it's really impressive to see that how far Taiwan has gone. And it's very impressive to also see the Delta floater animation. And we hope to see that in practice and a real sea testing for the futures. And next, our speaker is Ms. Stephanie De Decker. She's the Business Development Manager of Floating Wing for Bosklais Offshore. Bosklais is a well-known Dutch maritime engineering company, and they are currently just completing the Kinkerdam project milestones. And Stephanie has built up her experience in the oil and gas sector involving in installation of floating offshore structures. She's also promoting Bosklais' capability and fleet for the transportation and installation of floating wing foundations. Today, Stephanie is going to share with us the installation of floating wing foundations from the T&I contractor perspective. Let's welcome Stephanie. Thank you, Stephanie. Yeah.
Thank you, Jennifer, and thank you to the organizers for this opportunity to present here in this webinar. Next slide, please. So a few words on Bosklais. Bosklais is a Dutch dredging company and a marine service provider around the globe. We have about 10,000 employees working on several projects, and we make use of our own fleet, which consists of 650 vessels. We have been working in offshore wind from the early stages, and needless to say that, that the equipment used for the execution of the first wind farms was very different as what we use now. Challenging times, but which we overcame, we overcome, and also these projects were executed safely. In Taiwan, Bosklais has been present for over 30 years. We have a well-established partnership with Archie Offshore, and we execute projects together under the brand Bo-Wei. Our current activities, amongst others, are the foundation installation of the Shangfang Shida project, and we are also in country with our hog dumping vessel to do the scour protection on the Yunlin offshore project. So this year we had 6 vessels operating in Taiwan on several projects, and we'll have many more in the future. Next slide, please. So very quickly, we operate actually throughout the entire life cycle of a wind farm. That goes from the preparation phase all the way into execution, operation and maintenance, and decommissioning. We are well known on our activities in the bottom-founded offshore wind farms, but we have also a fleet which is very suitable for the installation of floating foundations, activities that we have been doing for many years in the oil and gas with installations of, for example, FPSOs. We have been participating with our vessels in most of the existing floating wind demonstrators farms in Europe. So Hywind Scotland, we were engaged in the preparation phases of Windfloat Atlantic, offshore Portugal. And last but not least, our most recent project was the transport and the installation of the Kincardine offshore wind farm. And as mentioned by Professor Hsiung Yang, this is today world's largest floating wind farm operating. And to get a feeling on the size of this wind farm, we will share with you a movie to get the perspective. So it's five floating turbines of 9.5 megawatts. Next slide, please, if you could start the movie. Okay. So the sound wasn't always very clear, but at least the images were. If we keep the movie a bit in mind, let's discuss a bit the typical challenges that we see from a T&I contractor perspective. So next slide. This entails actually the typical transport and installation activities. This means consultation and involvement in FEED stages of a project, the transport, wet or dry, of foundations or blocks of foundation components, the anchor and the mooring installation, the tow and the hookup of the floaters, with optionally, for example, also the inter-array cable installation. And then obviously, depending on the project, also operations and maintenance activity. Next slide, please. So my intention is absolutely not to sound negative here, far from. Bosklais is actually committing itself to turn challenges into opportunities, definitely when it comes about floating winds. So just here sharing a bit of a perspective on the T&I hurdles that we see. The professor also showed the many technologies that exist currently. A lot of technologies, very promising. But the reality of it is that not many have reached a proven technology level. So what will it be? Where, on which project, which concept will dominate? Something we're looking in a glass ball here. Also in terms of environmental impact, although it is clearly less than fixed bottom, it is still not completely clear. So a lot of people are worried, a lot of protest is happening. There is great potential around the world. France just launched its first commercial wind farm in Brittany. 10 parties are participating there. So who will win? Who will develop the project? What will be their contracting strategy? What will be their preferred floater? It's all unknown to date. The offshore and maintenance strategy is still under development. Will we be going back to ports? Will we find solutions to do floating to floating repair or change out of large components? This is all still under development. Also, offshore wind is a very local content driven market. This makes sense. People will be paying for the electricity generated offshore, so it's normal that they should benefit from employment on the projects. But also there, what is the skills and the workforce in country? As mentioned also by Barend Jenje, ports will need to develop themselves and look at area to facilitate a floating wind project. We're not only looking at fabrication areas, assembly areas, we're looking for also marshalling areas to have a fluent execution of the project. But the main activity of a port is the transfer of goods. So how do they fit floating wind projects into their daily activities? Next slide, please. Looking at the typical supply chain, there is a limited amount of fabricators which have the ability to fabricate 40 to 50 units in a 2-year season. That's a challenge. So where are the foundations coming from? We're looking at 50 megawatt turbines, which reduces the amount of the floaters, a good thing. So less amount of floaters to provide the total capacity of a wind farm. However, we are looking at floaters with the size of a rugby field. So as you can see here in these pictures, we had one floater for the Kincardine project on our barge Fjord, which is 60-meter deck area. So that gives a bit of a perspective, but transporting these items and using most of the deck capacity requires innovative solutions and transport taken care of from the early design stages. So you see in the bottom left, you see such an example which can lead on a good use of the deck area for transporting multiple floaters or multiple blocks of floaters. We also have workability challenges offshore. Areas with a lot of wind are usually also areas with a lot of waves, with limited installation windows per year. So access to the floater is a hot topic here. Best is an unmanned installation, and there's a lot of things being developed, so that is good. And last but not least, the governments are all committing to carbon reductions, but that means that a lot of projects are being developed in all areas. In offshore wind, we also see, again, a very good boost in the oil and gas, which increases demand of installation vessels. So as Bosklais, we have been investing heavily in additional tonnage, construction support vessels, tugs with a very high bollard pull. And that's how we look at it. So how do we turn these challenges into opportunities? Next slide, please. So Bosklais commits itself to tackle these challenges with the entire supply chain. We integrate supply chain considerations, but also transport and installation challenges early in the concept design. We do this together with developers, with concept designers. We bring a lot of knowledge also from the oil and gas. And we do not have to be blunt. There is so much knowledge there. Installations in 2,000-meter water depths are taking place. 10 FPSOs are being installed every year. So we should make use of this knowledge, and we should additionally look into how can we innovate the processes that we have been doing in the oil and gas. Clever solutions will bring these costs down, and within Bosklais, we are investing heavily with our R&D department to look into solutions for the transport and installation of floating wind and the seriality of it. Also, investing in local labor and skills, reskilling, that's an opportunity. Here in Taiwan, we invest in Taiwanese cadets on board of our vessels. We run traineeships with universities because sharing is caring. So we engage with the local players to make sure that they are ready for it. What is not in land, we can teach. And then we also engage with the supply chain, or common supply chain of mooring components. We look into opportunity where to set up additional factories, because a more diverse geographical supply chain will be a healthier supply chain. And last but not least, early engagement with a clear contractual framework is something we discuss with our clients. It's not a one-way conversation. We need to make this work together. So this is actually the conclusion of my presentation. We are investing heavily in this market. We believe in it. And challenges, we turn them into opportunities. Next slide. Yeah, this is the end. So thank you for listening. I'm happy to answer more questions in the Q&A. Do not hesitate to be in contact with Bo-Wei if you have questions.
Thank you, Stephanie. Thank you, Stephanie, for your presentations. And it's really great to finally see a short documentary of Bosklais installation on the Kincardine wind farm. And really hope that we can also see that picture in the future of Taiwan. And next, we'll welcome our next speaker is Dr.葛家豪. Dr. Ge is from the Swanco Renewable Energy, and he's the Floating Foundation Package Manager. He has 15 years of professional experience in offshore engineering and large-scale oil and gas project development, and has assignments around the world for multi-country EPCI project executions. And today he will share with us on floating floater local supply chain in Taiwan. Let's welcome 葛家豪经理.
Hello, aloha, and good afternoon, everyone. And my name is Chang Hako. This is my great pleasure and honor here and to share our thoughts on the opportunity, especially in Taiwan. As Jennifer mentioned, I was under several international assignments and aspects, and in 2019 to 2020, actually, I was relocated to Netherlands and living in Rotterdam together with my family. Next slide, please. And despite I know the Dutch people always are very tall, and the weather in Netherlands sometimes kind of chilly, windy, and I do find there are several similarities in between Taiwan and the Netherlands. And we have a very similar size of land area, and also in terms of population-wise, we pretty much both the Netherlands and Taiwan, we have very similar the same scale of populations. And also in terms of industry, the key industry focus, I also found that we have very similar like a focus on the industry, like the high technology, like both we have very good semiconductor industry here, and also we also focus on life science and the maritime, and in terms of energy and chemical, especially on petrochemical, we also kind of a very good focus in between the Netherlands and Taiwan. And most important, also and the Dutch people like to ride the bicycle. And you see the picture the left hand in Netherlands, in we bought the local called the fietscargo bike, or they like to use this kind of bicycle to transport, to ship their children as well as the dog. You can see a picture. And also interesting, I found that although the bike is a brand with a Dutch brand, but actually I did find there are several parts actually made from Taiwan. Now I ship this bike back to Taiwan, Taipei. So maybe later on you can find sometimes I ride this bike to take my son or my dog just ride on the Taipei cities. So all in all, I think in Taiwan and the Netherlands, we have a very close economic relationship, which has been established since 400 years ago. I do believe we will have a more collaboration opportunity come from floating wind business. Next slide, please. So I would like to give a quick introduction, provide a quick instruction for our company, Swanker Renewable Energy. Actually, Swanker Renewable Energy is a Taiwan-based developer. We have developed very first offshore wind farm in Taiwan, which is called the Formosa 1. With this very first offshore wind farm development, we also made a lot of the very first achievement in Taiwan. Like in 2014, we obtained the very first fisherman and the regulatory approval for offshore wind farm. And also in 2015, we built the very first offshore mast in Taiwan for offshore wind farm development. Also, for project development, we also needed to go through all the financing work. So in 2018, we got the very first offshore wind project finance in Taiwan. So today we are continuing to operate this very first offshore wind farm, which is Formosa 1 in Taiwan. Next slide, please. So also I want to share some of our information about our wind farm portfolio. As I mentioned, the Formosa 1 right now is under operation with a capacity about 128 megawatts, and Swanker is operating as an OEM operator for this wind farm. And also for another one is Formosa 2, which is with a capacity about 376 megawatts, is right now under construction. We do believe the project will be online very soon. And meanwhile, for the upcoming the third round, phase 3, the development, we are also developing the Formosa 4 and the Formosa 5 projects. If you can see the picture in the right-hand side, you can see the Formosa 4 and Formosa 5 actually is further far away from the shoreline compared to Formosa 1 and the Formosa 2, which is about roughly maybe 20 kilometers away from our shoreline. And this means in this area, the water depth will be much deeper than the Formosa 1 and the Formosa 2. So we intend to bring the first large-scale floating offshore wind farm to use this technology in this project development. Next one, please. Next slide, please. Thank you. So please go back. Yeah. One slide. Yes, thank you. So actually, if we look at the history about the offshore wind farm development, the very first, the bottom phase offshore wind farm was established, built in 1990. And today it's about 30 years ago. And the industry has been very mature with very good opportunity, with good technology, and also well-developed industry. Which means if as a Taiwan now we want to catch up, this will be a long or big step we want to catch up. But if we are going to look at, if you look at the floating wind industry, the very first full scale the floating wind turbine was developed in 2009, and following the very first multi-turbine floating wind farm was built in 2017. Today is 2021. If we consider 2017 or 2009, the gap of timeline is not so huge. So which is creating an opportunity for Taiwan to catch up. And not only for Taiwan, there are also some actual factor advantage right now is waiting for Taiwan. One is we have a strong local demand. Because our government, the plan and the vision, we will have plenty opportunity to develop the renewable and green energy in Taiwan. And also, Taiwan has been very famous, have a very good reputation to develop and manage new technology. So with this kind of new technology from the offshore wind, floating wind perspective, we do believe this will be a good opportunity and also the good strength for Taiwan to demonstrate how we can manage and develop this new technology, emerging technology. In addition, Taiwan, we also have very good existing industry foundation. We have a shipyard, we have a very some good the steel fabricators, and also we have several very good harbors which can allow support this floating wind supply chain in Taiwan. So not only in Taiwan, right now, from a global perspective, like Japan, like Korea, many countries, many locations, many people are talking about floating wind now. So then we do believe not only for Taiwan, down to the road, we may also have opportunity to use the technology, to use our fabrication capability, even the project management expertise to support the floating wind farm development worldwide. So we do believe the floating wind is the blue sea opportunity for Taiwan. And also right now we are going to more focus on the foundation perspective. Next slide, please. So there are four the major the stage of like project development for floating wind project. So the very first is from the engineering, floater design, and the mooring design engineering work. And compared to the bottom fix, the floater is much more sensitive to the environment load, like the wind, wave, and the current. So in the very beginning, we needed to pay a lot of attention to make sure we have a good defined meteorological criteria as well as the geotechnical information. Meanwhile, we will heavily to use our local infrastructure, for example, the fabrication, the harbor, the shipyard. So we also needed to have very good understanding about all this information and the condition for this infrastructure. And also we needed to understand what is our strength, our fabrication, what is our local expertise and experience. All this more information needed to be collected, input, and use our very initial floater and the mooring design. And then next to move to the next stage. Once we have the design and we can move to on the fabrication. So as the speaker mentioned, right? If we're talking about the 500 megawatts of wind farm, if we are going to use a 14 or 15 megawatts wind turbine, so we will need to build, deliver, and install maybe 30 to 40 floaters in the very short period, maybe year 1 or 2. So this will be a massive and serious local fabrication, and which require well-planned execution and logistic management. And meanwhile, because by nature of floater, we will have plenty opportunity. We need to use our harbor extensively, like for temporary berthing and some storage. So once we finish the fabrication and the supply, and then we need to move to a next stage, which is the floater mooring and installation. And there are three major steps we need to consider. The very first is we are going to tow the floater from the fabrication yard or site to the wind turbine integration harbor. The most important of is that we can integrate the floating the wind turbine onto a float at the quayside, which require some land to do the pre-commissioning for a wind turbine. And meanwhile, we are not only to work in the quayside, and also we can do offshore mooring installation and anchor installation. Once all these two activity has completed, then we can tow our floater integrated with the wind turbine out from the harbor to the site for the final hookup and the commissioning. And then we move to the next stage, which is O&M. And I know right now in our floating winds or even the offshore winds in Taiwan is still like in the early stage. So usually we are more focused in talking about the project development. But for me, the O&M is the most important stage of the project life cycle, because we are going to operate and do operation for this wind turbine, these floaters for 20 years in our Taiwan area, the Taiwan Ocean area. So we will do all the kind of offshore inspection for asset health monitoring, integrity management, and also potentially we need to repair offshore. And also we are not dealing with one or two floaters. We are talking about tens of down to the could be hundreds of floaters with plus the several tons of mooring system or maybe cables. So all these kind of stage will create a lot of new local supply chain opportunity as well as challenges. So please, next slide, please. Thank you. So then with this kind of opportunity, what is our consideration or key strategy for local supply chain engagement in Taiwan? I'd always say the very first important is technology, and the technology is from people. So we are focusing on talent development and local people development. And in addition to local people, right now it's the global world, global village. We also continue to look at, to acquire the professionals, the knowledge international wise, and also we would like to mobilize the professional people to our team to focus on technology development. In addition, is the fabrication. As I mentioned, Taiwan has a very good foundation for fabrication, but when we talk about the floater fabrication, this will be different stage. So we needed to improve for our quality and also advance our production capability so that we can deliver the floaters, several floaters in a year or 2 years down the road to support all the project development. And so Stephanie, she also mentioned from T&I perspective, I think the mindset is totally different from bottom fix. Likewise said, we need to tow out the floater in between the harbor, and we can do the wind turbine integration just in the quayside. And also, because by nature of floaters, maybe we can do like the storage not on the net. We may consider to do the storage just in the near shore. How we can manage, how we can find the new way for all these kind of new transportation or logistic challenge is rely on visionary and agile innovation on the T&I perspective. And the last, not the least, is always O&M. We need to have a very sustainable and responsible execution team to support the long-term, the 20, even 30 plus years operations in Taiwan for the local perspective. Please, next slide. So this is my conclusion, and also want to share with the audience about the strategy approach that SRE are using and considering. There are 4 major elements. The first element is very important, is the people. we have a Taiwan-based technical and project management team here for a long-term development perspective. And also, meanwhile, we are engaging with the international concept and the service providers for this floating wind project development, not only through engaging them, also we want to bring this knowledge and the technology in Taiwan. And in addition, we also collaborate with the local academia, research, and the industry partners, not only to acquire local knowledge. The most important is we want to develop our local people, our local expertise. The next element is a value. Our focus, our major focus for the project development is we want to maximize the stakeholders' benefits. So we have initiatives on the value chain development to collaborate with all the suppliers. And also we focus on the optimizing the design so that we can enhance the local supply chains opportunities to support the floater project development. The next element is experience. As I mentioned earlier, we have developed very first offshore wind farm in Taiwan. So we have proven in-house experience. And so this experience can be used for further develop our floating wind farm project. And also we are very familiar with the local harbor conditions. The last element is also, I always say, the best and most important is sustainability for long-term run. We have a Taiwan-based O&M team with a proven track record. With this O&M team, we can get the local and the very first-hand O&M knowledge so that we can use this knowledge to further improve our design and the fabrication and also the technology development for floating wind farm development down to the road. So with these four major elements of our approach, we believe we will have a very high project execution certainty to develop very first floating wind farm in Taiwan. This is my presentation today, and thank you so much. If you have any question, please feel free to reach out to me, or I can answer during the Q&A session. Thank you.
Thank you, Dr.葛家豪. And it's really nice to hear about Swanco Renewable Energy's ambitious and about floating wind farm in Taiwan. And also we learned that for the 4 elements, and we expect a great team expansion for Swanco Renewable Energy. And next, let's welcome our next speakers, Mr. Francisco Pina Rodrigues. Yes, he's the global segment lead of offshore wind in Mammoth. And he has 8 years experience in offshore wind with numerous executed projects, including offshore transportation and installations of foundations, and also turbine fabrication interface on onshore logistics and storage and pre-assembly. Mammoth, for now, has over 8 floating wind projects around the world completed, experience in Japan, Portugal, and Spain, and Norway, and France. And today, Francisco is going to share with us on floating wind assembly. Let's welcome Francisco's presentation. Hi, friends. Hi, friends.
Hello, good morning, good afternoon, everyone. Thank you, Jennifer, for the introduction. Thanks, everyone, to the Holland Home Wind Energy and the Netherlands Taipei office for the invite and for bringing together such a great group of Dutch experienced companies. My name is Francisco. As Jennifer said, I'm global segment lead of offshore wind within Mammoth. I've been working for 8 years in the industry, and I'm leading also the floating wind developments within Mammoth since 2019. Next slide, please. Next one. As we start, just a couple of words on who we are. We are the world's largest heavy lift and transport company. Since 2020, Mammoth and ALE have joined forces, and currently we're working in over 90 offices, operating in more than 45 countries. Mammoth is also part of the SHV Group, which is one of the largest Dutch family-owned companies with a strong position in a number of operational areas and the selected investment activities, and also with a long-term focus on sustainable growth. We are currently over 5,000 employees with a yearly turnover of approximately 1 billion euros across all the regions. Next slide, please. So, as Mammoet, we provide solutions to any heavy lift and transport challenge. The way we do this is by operating the world's largest fleet and pool of equipment, from smaller to larger crawler cranes, from trucks to SPMTs, barges, transjacks, and others. Together with our R&D department, we keep on pushing boundaries and innovating beyond what we imagine. And large part of our equipment is also in-house developed and tailored designed to suit our clients' needs. Next slide, please. Being part of the renewable market for the past 15 years, it's also, of course, our responsibility to think about our emissions and also making all efforts to reduce our carbon footprint. To achieve this, we do have a clear pathway till 2030 and beyond on how we're going to develop internally and with our supplier this pathway. This includes, of course, the bringing electric cranes, hybrid vehicles, electric SPMTs with power packs are just amongst a list of efforts which we are doing very, very hardly with our R&D to achieve a clear target of having already by 2030 30% of our equipment which can be carbon neutral in all our fleet. Next slide, please. Also important to say at last from our side, we're working in Taiwan since 2018. We currently have over 100, almost 150 full-time employees in country, together with our valuable and good partner Giant, and we've been jointly working, investing and supporting the offshore wind in numerous projects, such as the Formosa 1 Phase 2, which you see here in picture, the first project offshore wind executing in Taiwan, but also more recently during the pandemic, we've been working on Yunlin in the Anping port, Crater Shangwa in several locations along the west coast, and also recently in Shanfang Xidao in Taipei port. So next slide, please. I'm gonna just next one, give you a little bit of a background on what we have so far done in offshore wind. These are just a couple of numbers as part of the experience we have built through Taiwan and globally. We have currently over 1,000 monopiles and almost 1,500 turbines safely either handled or lifted up till now. If we move on, next slide, please, and focus on the floating wind developments. So if we zoom on the floating wind, as Jennifer mentioned, we've been participating in over 8 projects, and we are happy already to say that we can leverage from that experience and aim to bring the lessons from the first prototypes and pilot projects which were installed in the world, which also include in our case different types of floaters and different types of turbine sizes. Next slide, please. If we look at the global map, our experience started from 2014. On the right-hand side, you can see a picture of when we started part of the Fukushima installation, the Mitsubishi turbine, 7 megawatts installed in Japan. And from that moment, we have participated in mostly all of the wind prototype and pilot projects which have been done in Europe, such as High Wind Scotland, the Wind Float Atlantic in Portugal, more recently the Kincardine in the UK, but also the FloatGen barge concept in France. In these projects, our scope varied from floater fabrication assistance, floater launching, and the turbine integration at the quayside. We are also very happy to announce that in the next quarter, so Q1 2022, we will be installing 11 8-megawatt Siemens turbines for the High Wind Tampen in Norway. Next slide, please. So what we do in the industry, our scope of services cover a large part of the life cycle of the wind park, but our main core business is on the assembly, on the construction phase. So initially, the scope varies from FEED studies together with the developers and now OEMs. We are very involved in let's say, port feasibility studies, but also in changes that can be incorporated both in the floater and the turbines to facilitate and to improve the way these are handled, lifted, and to improve the process throughout the life cycle. It is also, of course, during this initial phase that our R&D teams are bringing new ideas and concepts as we're constantly trying to innovate and also become a little bit more efficient on the way we handle things from a both cost and time perspective. If we move on to the second one, then we, of course, support fabricators during their assembly phase of foundations, floaters, and moving on, we work closely together with the EPCs and the OEMs during the transport, the storage, and the load out, the launching of these large components across different countries. At last, and as floating wind continues to grow, we are hoping to expand our scope to the installation of the turbines, but also in the operation and maintenance phase, the actual maintenance of the wind turbine throughout the complete life cycle of this unit is an area which we are looking into. Next slide, please. So to give you five areas which we are focused on the R&D phase. So the first one is the first area which we are looking into are the ports. So the assembly phase and how to best make use of ports, knowing this is an area where I think the industry is aware that is not always, not all the countries have the right ports or the ports necessary with the space and capacity for these type of projects. We're supporting the industry in ensuring that suitable ports are available for floating wind. We do this in numerous ways. Sometimes we do engineering studies, or we do checks on existing facilities or new builds. But also we have two examples of jobs executed in Taiwan where we were actually responsible for upgrading the conditions needed at the port to execute these works. So this is something where we also have experience with. The second topic where our R&D teams are investing hardly is on the floater launching and the challenge to move 3,000, 5,000 ton, 10,000 ton structures from the quayside to the water. We're also putting efforts on the cable pull and the mooring tensioning, either works to be done at sea and also in the port. Obviously, the fourth topic is a very important one. It's understanding the next generation size of turbines and also what are the needs and the design requirements for new equipment or for changes on existing one. And as last, the OEM and the turbines maintenance, either if this is going to be done at sea or in a harbor. Next slide, please. So trying to capture some of the lessons based on the experience we have been carrying on from the 8 projects executed, but also the R&D we have been doing. Mainly, one of the challenges we see in the assembly and the fabrication space is the lack of space and the technical, let's say, requirements which are needed to overcome the ground conditions at the quaysides, meaning very heavy floaters that need to be produced in series, but also not only the way you need to assemble these, but also the engineering behind the storage and the movement of all these components. One of the challenge we identify is moving from a prototype mentality to a serial production mentality, which is where time is money more and more. And we feel that one of the ways that we can improve and speed up the construction of the floaters is by taking a modular approach and to have as we have done in several other industries in the past. One of the examples we can give is in the bottom left picture of this slide is a project we have done, the Wind Float Atlantic project, where we assisted the client to basically transport bigger and reduce, so basic transport columns of up to 1,000 tons, which allowed the client to reduce their assembly times. And in this specific case, the time needed to have the floater built in a dry dock, so therefore reducing dry dock space over time. Next slide, please. If we look then at the launching, placing floaters in the water is a big task. Commercial scale, we feel that commercial scale projects require innovation, investment in some cases, and in a lot of places in the world, when we bring commercial scale projects, we also aware that there are reduced installation windows where these floaters can be installed. And therefore, the target we have and that we've been given is that we need to basically be able to put one floater in the water every week. And this floater needs to be ready to receive the turbine in that period. We as Mammoet feel that to do this in a commercial scale and in repeatedly and in a cost-efficient solution, this needs to be done by placing the floater directly in the water, right next to the quayside, and by then avoiding doing submerging operations, which we know they work, but they're also sensible and can be quite impacted by weather or water depth and locations where these can be done. Next slide, please. So if we then look at the turbine installation, the integration of the turbine in the port, a floating wind basis is to avoid large and expensive jackups, although these are also an option to overcome a challenge, and in some cases they can also be used. The main issue that we see is that the pace that turbines are growing are reducing the size, the availability and the size of cranes that can do these operations. The increasing weights and the hub heights that we see on 12, 14, 15, 18, 20 megawatt turbines reduce the amount of cranes from an onshore, but also from a jackup point that are able to install this next generation of turbines. Of course, we operate land-based cranes only, and to give you our perspective from a heavy lift crane operator, which owns the largest fleet in the world, we currently at this stage, so end of 2021, we have 10 cranes which are existing, they are built and they are available, and they are capable of lifting 12 megawatt units on floater turbines, either central columns or side columns, if we want to call it like that. And if we look at what's coming afterwards, our initial studies show that we currently already have 5 units, 5 cranes ready to serve the, let's say, the 18 to 20 megawatt market, which we expect to be ready by the end of these decades. We are also conscious, of course, that there is demand from other industries, and therefore we are developing our R&D to not only upgrade some of the existing machines, but also to bring new assets in the market and to prepare for the future 2030 up to 2050 demands worldwide. So expect, I think, from our end, some news in the first semester of 2022 already on that behalf. And one of the last topics, next slide, please, the maintenance topic and how we're going to see the strategy going forward. I think this is still an area which is under consideration. Option 1, bringing the floater to a port, has definitely advantage in some areas, but it also has a lot of questions behind it, which are the requirement of a big port, and the big crane being ready and available to replace a blade or a generator at 150-meter height. This is not always the case, and it's not always that you have such a crane or a port ready and available for you to tow back to port. On the other hand, you can see on the right-hand picture, Mammoet has been looking since 2019 also at other options on how to perform these activities, either inside the harbor in safe waters, but also offshore, by using climbing cranes or self-mounted cranes on the turbine to reduce the downtime of the wind farm and to bring the OPEX cost of floating wind down over the full lifetime of the project. So just to finalize, next slide, please. So next one. We feel that though floating wind is a new industry, we as Mammoet can bring over 50 years of experience, which we can carry from other segments and industries. So you might think that moving 3,000 tons is a crazy task, but it's actually what we do on a daily basis around the world. And I think we believe that floating wind can definitely learn from mistakes in previous industries and make its way to be a leading energy source by 2050. We also believe that Taiwan has the right supply chain in terms of fabrication, in terms of port, in terms of R&D to definitely achieve these tasks and be also a leading country in this type of technology. And as Mammoet, we are definitely ready to offer our worldwide coverage, our network, and our experience with the ability to invest and to follow the market, but also keeping our CO2 emissions to the minimum. So thank you for the time, and that was me for today. Thanks.
Okay. Thank you, friends. Thank you for your presentations. And we really now we know the overall how much service that Mammoet could help on the floating wind farms, and hope that someday that also we can see the project in Taiwan as well. And then since we'll have quite a delay in the webinar, and now we're going to enter our Q&A sessions. And today we're going to welcome our Managing Director, Ms. Arjen Schouten from the Holland Wind Energies. And Arjen is also the main lead of the Taiwan and Japan and also France and US offshore wind project around the globe for the promoting Dutch supply chain. And today he'll be moderating our Q&A session and also the main takeaway. The stage is yours, yes.
Yes, Jennifer, my first question to you is how many minutes do we still have for the Q&A? Because I can imagine that all people are quite busy. Jennifer, how many time do we still have?
I think we should be controlled within 20 minutes. That will be
20?
still 15 to 20 minutes. That will be still fair enough.
Is that okay with all the presenters? Do you have the time? Can you please? Yes. Oh, yes. Okay, great. Then, well, thank you all for your beautiful questions, for your beautiful presentations. My first questions to you is to the presenters. From the Dutch side, from Jos, Barend, Stephanie, and Francisco. Do you have any questions to the Taiwanese presenters yourself? There's something remarkable or that you would like to ask? No? Yes? Maybe?
If I can go, yes, Arjen, thanks. I would have a question to the Taiwanese team. And it was very good to see their presentations today and what has been done in Taiwan already. It was more from maybe a high level policy. How does the maybe Swancor or the from a university level, how does Taiwan see the floating wind market becoming, let's say, taking off in Taiwan in terms of what steps are still needed to bring floating wind forward from a governmental level and push that in Taiwan.
Okay. Can you all give us very short reaction? Professor Zhang, Dr. Zhou, and Dr. Ge. Let's start with you, Professor Zhang.
Yeah, okay. Yeah, I think that this is in my presentation. By 2035, we still have 50 megawatt, and at least 10 gigawatt will over other days, 50 meter. Yeah, so floating wind actually has quite potential application in Taiwan. But the problem is the timeline. When will be the demand? And because next year the first the bidding for the phase 3 will be open, and if we now or next year we in the project wind farm development project and the floating wind is still not so mature, and maybe 2 years later, and it will become more mature technology, and the cost will be down, and maybe it will be more compatible in compare with the bottom fix. But if you see in the book until 2035, I think the demand is no problem. Yeah.
Okay, thank you. Dr. Zhou, can
Yes,
briefly give
yes.
Yeah.
Actually, as a think tank of the government about many marine affairs, that I think that the most important for us is how to help the local industry to participate this supply chain. So that we do some work, and the process, the concept design is not in order to let the outside world to understand we are not empty in this area. Maybe we are not to the like a Gusto layer do a little more further than us, but still we have to some place more comparable job, and we are closely correlate with local industry, so we can keep an eye and up to date to follow the trend. So I think that's very important, and we are open to cooperate with the other design house company to do the job. We are not saying, oh, all the design must be from Taiwan. No, actually it's who is the best solution that will be adopted. But we hope that all the experience, that kind of can be kept in Taiwan, and everyone here can understand us. We can prosper together to do the job. So that's the main goal. And to let you understand, that's here another thing. Also, the partner in Taiwan can do. I think that's a great opportunity to let us show that our goal and the level, the current technology level to do the job.
Thank you. Dr. Ge, maybe some comments or?
Yeah. So very quick, as my presentation, we intended to bring and establish the very first offshore floating wind farm in Taiwan in a commercial scale. So also many presenters also share, there are plenty of new challenges, new issues we need to handle. So for us right now, we are not only to do work by ourselves, also we collaborate with the local academia, supply chain, as well as all the international players. Like I really appreciate we have this opportunity to listen from like the Stephanie and from the Gusto and also from the Mamu. And I do believe we have some connection already existing, but we will continue to collaborate each other to exchange some opportunity to explore more opportunity. We can develop the floating wind farm in Taiwan together. Thank you.
Thank you. And then I would like to ask, I think that Francisco Rodrigues has to leave in 5 minutes, but let's proceed a little bit with the Q&A. From Taiwanese side, do you have any questions to the Dutch presentations? Professor Jiang, Dr. Ge, Dr. Zhou, do you have any questions to any one of the Dutch presentations? Yes, Professor Jiang? You're muted.
Sorry. Okay. Yeah, my question is for the infrastructure of Taiwan, because if we would like to promote the localization of especially the infrastructure, will be very important. And do you have any suggestion for the infrastructure like harbor or or what we should do first before we commercial the floating wind commercial wind farm?
Francisco, can you maybe give a quick answer to that before you leave?
Thanks, Doctor, and thanks, Aaron. I think Taiwan is a good example on how our offshore wind has been built, and I believe that from an infrastructure standpoint, if we compare to many other ports in Europe, which are already trying to push commercial wind farms, Taiwan has that infrastructure, and he's developing that infrastructure. Of course, if we say we're going to go for a 1 gigawatt project straight away, that might be challenging. But I believe that both in the West Coast, from Kaohsiung up to Taipei, there are several very good capacity quaysides with interesting water depth and with the space needed, with the right fabrication to already start off and have a good basis without a lot of strong investment needed beforehand.
Any additional comments, Stephanie, from your side on this?
I think I tend to agree with Francisco's opinion. Indeed, there are the infrastructure is in place in Taiwan, and I think we also need to put it into a certain perspective, of course, like how large do you want to go? We need to find like the right balance on the required quayside space compared to the actual size of the wind farm. And we need to stay realistic in that point, because we cannot just go and spend hectares of areas on this project. That's these kind of projects, that's not realistic. So in that sense, the infrastructure, how it is now, is quite well developed compared to other countries, indeed.
Maybe we're really coming to the end of this webinar. I would like to ask a short question to everybody, and with a short answer. And I would like to give first start with Jos, and then Professor Jiang, and then the other speakers. But in a dream world, if what kind of major challenge in floating wind do you really want to be solved as soon as possible? Jos, maybe I'm...
Because in Taiwan, we have typhoon and earthquake, and how to verify the floating structure and the mooring system can be survived under such severe condition. I think is our concern.
Yeah, key question. Yeah. Thank you, Professor Jiang. Jos, any from your side?
I do not think there are unresolvable problems in the wind energy technology, but the electrical or gas infrastructure, I think that's key. Before a significant startup can take place. So the major challenge, I would say, is getting the energy infrastructure at those places where the floating wind farms will be built.
Okay, thanks.
In advance of the activities.
Yes, Dr. Zhou?
Yes, in my opinion, to find out what's the economically feasible solution for the mooring system is in this kind of shallow water. It's called this kind of floating shallow water. That is, I think the technology for this is available, but cheaper enough to promote this industry is what I concern most.
Thank you. Dr. Ge?
Yes, okay. I would like to echo both the two professors. This is the economic viable solutions because in Taiwan, our environment is very challenging. Like we have harsh environments in Taiwan, and also we need to deal with earthquake, potentially the soil liquefaction. So this will be one economical viable solution with the key. And the second is the solution on the supply chain management, especially logistics. How we are going to build these several big monsters and also do like a one-time tow-in, tow-out storage, either onshore or anchorage, temporary the storage. All this information and the plan needed to be done. Thank you.
Thank you. Barend?
I tend to agree with Professor Ke. It's indeed, it's all about supply chain. I would like to see participation of both industry and government to make this happen. There's currently already a large fixed wind industry in Taiwan. In addition to that, an even bigger industry will be upcoming when it comes to floating offshore wind. So really structural, infrastructural changes need to be made, investments need to be made.
Thank you. Then Stephanie?
I tend to agree that for Taiwan, indeed, a big challenge is indeed your environmental conditions that you have at location. But if we bring it a bit broader to floating wind in general, then how will a typical 25-year O&M campaign look like? And how can we bring this as into the early stages of the design of such a project? That would be my question.
Thank you. Francisco, still time for a last remark?
Well, I was going to say I agree with Stephanie. I think for us the main thing which we believe it's the O&M and the maintenance over, and the OPEX cost has a significant impact. And if we want to bring this to a commercial scale level, I think this needs to be tackled and together with the OEMs, developers, and the supply chain.
Thank you very much.
Thank you.
Francisco. And if you have to go, please go. Thank you very much for all your presentations. And now we also have assembled some topics for the next webinar that we can do. Hopefully we can do it in real life. However, yes, with this new variant in COVID, we don't know when we can travel again to Taiwan. I really want to thank you. Before handing over to Jennifer, I really want to thank you all for your wonderful presentations. Also very excited that I learned from the Netherlands Bureau in Taiwan that floating wind will be a leading topic for the next years. So yeah, also for Holland Home of Wind Energy, floating wind is a very important theme. We are already involved in many projects around the world, and we will focus also on the developments in Asia, not only Taiwan, but also Korea and Japan. So thank you all, and I would like to hand over to Jennifer.
Thank you, Aaron, and thank you for all the speakers and participants. We want to thank again for everybody participating our webinar today, and we do look forward to have a future communication with all the audience on floating wind topics. And we do know that all the participants are really eager to have all the speakers' presentations. And we will send the presentation files once we got the speakers' authorizations, and we will send them via your emails. So if you all are you all have registered on our websites, then we do have your data. And if you didn't register on our websites, please do send us an email for your requires. And we do look forward to meet you again online. And thanks for your participation again. Bye-bye.
Right.